Alright, geometry, this is our last Edpuzzle video assignment before the test. Alright, so Unit 1 summative review. We're reviewing everything we've covered so far in class. So, vocabulary. Angle, two rays or two line segments. You know that these are rays because of the arrows. If they were line segments, it would just end in a dot. But they share a common endpoint. So my common endpoint is right there. A line. Line of points that extends infinitely. That word infinitely is important in two directions. So you can see the arrows going both directions show that it extends infinitely. And here's a notation for a line. All right, a line segment is the 2 points and all points in between. So it's A, B, and every point that connects them. It does not go on infinitely. They end, right? A circle. Set of all points in a plane that are a fixed distance, and that fixed distance is known as the radius. So fixed distance from a given point. All right, parallel lines, two lines on a plane that never intersect. They are always equidistant apart, so they go on forever and never intersect. Perpendicular lines do intersect, and they intersect in a special way. They form 90-degree angles. That little box designates 90 degrees. So these are all 90-degree angles. All right? So just make sure that you're familiar with these definitions. All right, we learned about 4 major transformations. This was number 1, translations. Remember, translations are rigid, same size, same shape, and they result in congruent pre-image and images. All right, so you're sliding the 4 major directions, left, right, up, and down. A change in the x value can move the figure left or right. If it's a negative, you're going left. If it's a positive, you're going right. A change in the y value moves the figure down and up. If it's a negative, you're going down. If it's a positive, you're going up. All right, the 2 types of translation notations you might see is a translation notation or a mapping rule. With translation notation, the numbers right here are your rule. The first one corresponds with the x value, and the second one corresponds with the y. Just pay attention to the signs. If they're positive, you're going right or up. If they're negative, you're going left or down. All right, so here are some examples. I want you to go ahead and pause the video and try doing example 1 and example 2. Here's example 1. You'll see that we moved the figure right 4 spaces and down 5 spaces. So just take each point and count 4 to the right and 5 down. So your new figure should look like this. Be sure and label your points with the primes. And you should be able to tell that you did it correctly because the figure should be the same size and shape. We just shifted it right and down. All right, go ahead and try example 2. Your image should look like this. So we're going left 3 and down 4. My x value is negative and my y value is negative, so we're going left and down. So remember, this is my pre-image, this is my image. It should look like I went left and down, and they should be the same shape and same size. That's how I know I did it correctly. Remember, the primes are labeled with the apostrophe symbol. All right, that's translations. Let's go ahead and go to reflections. So this is a type of rigid transformation in which the pre-image is flipped across a line of reflection to create the image. All right. So we have our important rules. All right. So let's go ahead and try some examples. The vertices of triangle ABC are here. If ABC is reflected over the x-axis, what are the coordinates of A prime, B prime, C prime? So let's look at our x-axis rule. Our x-axis rule means the y value is changing sign. So xy becomes x negative y. So all I'm going to do is circle the y value of my pre-image points. So I know my new A prime My x value stays the same, and my y value becomes negative or positive depending on whatever it was before. It was positive before, so now it's negative. My b prime, I keep my x, and that positive 5 becomes a negative 5. My c prime, keep the x value, and the y value flips the sign, so that positive 2 becomes negative 2. Alright, so what about if those pre-image coordinates were flipped over the y-axis instead of the x-axis? Alright, so I know that my y-axis rule, and I can just go up here, my y-axis rule is x comma y turns into negative xy. So now on my pre-image point, my x value is the one changing the sign. So if my x value is changing signs, I'm going to circle the x value. Alright, so looking at these pre-image points, I know that my a prime would now be negative 2, positive 2, because my x value changes sign. My b prime would be negative 4, 5. Remember, the y value stays the same. And my c prime would be negative 6, 2. Alright, what if these pre-image points up here were actually reflected across over the origin, which is y equals negative x? Y equals negative x, my rule is that xy turns into negative y, negative x. So I need to change both coordinate signs and flip them. Alright, so let's see. My pre-image point is 2, 2. If I change both the signs, negative 2, and flip them, it's going to be negative 2, negative 2. The flip doesn't make a difference because they're the same number, but it will on the other points. Alright, b prime. I have a positive 4 and a positive 5, so I change both of those signs to negative and flip their positions. So now I'm going to have a negative 5, negative 4. You just switch their positions and change both the signs. Same with c prime. Change both the signs and flip their position. The 2 was the y value, now it's the x. The 6 was the x, now it's the y, and they both become negative. Alright, on our last rule, what if we flipped it over the line y equals x? So if we flipped it over the line y equals x, that's our last rule listed here. All we do is flip the places. The y value now comes first and the x value comes second. Alright, so let's look back up at our pre-image. For a, it doesn't matter because they're the same number. So when I flip positions, it looks the same. b prime, instead of 4, 5, I'm going to have 5, 4. And c prime, instead of 6, 2, I'm going to have 2, 6. So these are all the 4 different rules that you need. I would keep this in front of you, this rule sheet in front of you during the test. You also need to be able to identify the line of reflection. So looking at this, it looks like this figure was flipped over the x-axis. The x-axis as an equation is written as y equals 0. We know that it's a horizontal line and it hits the y-axis at 0. Every single y-coordinate for every point on this line will be 0. Alright, this one you can tell it's being flipped over a diagonal line that's going up from left to right. A diagonal line will have both variables, y and x, and it will also be positive because it's going up from left to right. So y equals x is the equation of that line. Here, the line of reflection is a diagonal line going down. You see how we just flipped it across that diagonal line, so if I folded it along that line, these points would match up. So this is the line y equals negative x. It's got 2 variables, that's why it's diagonal. And then it's going down from left to right, which is why it's the negative x. Alright, that's it for reflections. Just kidding, there's a whole nother page. Alright, what is the line of reflection? So they've highlighted it for you here. I think we've done this question before, but it's just a review. A horizontal line is always going to have the variable y, and it's going to equal where it hits on the y-axis. So this is y equals 1. Notice that there's no x in this equation because the line is horizontal. A diagonal line would have both variables in it. All right, here, reflect over the line y equals x. So here's going to be our line of reflection, y equals x. And we're going to take the pre-image points and reflect them. So my pre-image A is -2, +3. My pre-image B is -3, 1. And I'm just looking at where they are on the coordinate plane. And this is -1, +1. All right, so we need to use our reflection rule. If we're reflecting over the line y equals x, we just flip the coordinates. So what will my A prime be if I take this pre-image A and just flip them? Now it'll be 3, -2 instead of -2, 3. For B, let's just flip these two places. Instead of -3, 1, it's going to be 1, -3. And C, I flip these two, it's going to be +1, -1. All I'm doing is flipping their position. Now let's go ahead and graph it and see if that worked. See if it looks like a reflection. Does look like a reflection. If I were to fold this over that yellow line, C and C prime would match up, A and A prime would match up, and B and B prime would match up. So it's a true reflection. All right, I want you to pause the video and try this next example on your own. Go back and look for the rule, write out the pre-image points, and then use the rule to find the image points and graph them. Okay, so you should have written out these pre-image points. A is 1, 1, B is 5, 1, and C is 1, 5. The rule, if you go back and look, the rule for reflecting over y equals -x is that xy becomes -y, -x. You flip the two and change the sign. So you'll see that A becomes flipped and both of them are negative. B, you flip the positions, change both the signs, and C, flip both the positions and change the signs. When you graph it out, you'll know you did it correctly because this looks like a true reflection, where if I fold it over that line, the points will match up exactly. All right, pause the video and try this example. Reflecting over the x-axis, use the rule. Okay, here's what your image should have looked like. So if we're reflecting it over the x-axis, you'll see that I could fold that x-axis and the points will line up. I flipped it over. So I found the pre-image points for each one. Y is 0, 2, T is -4, 4, and I is -5, 0. So all I did was I changed the sign of the Y. That's my rule. So everything changed except for the 0. The 0 stays the same because you can't have a -0. So that point I is exactly on the line of reflection. All right, go ahead, pause the video and try the next one, reflecting over the y-axis. So this is what a reflection over the y-axis would look like. I have the same pre-image points, but instead of changing the y value, I changed the sign of the x value because that's my rule. So now I should have 4, 4, 0, 2, and 5, 0. And you can see it looks like I flipped that pre-image over the y-axis. This time, point Y is on that line of reflection. Over here, point I was on the line of reflection, but since we're reflecting it over a different line of symmetry, Y is now on the line. All right? Identifying reflections. So what we're doing here is we are just figuring out what's the equation of the line of reflection. So it looks like they're drawn for us in all these pictures, and you can kind of confirm, like that's flipping over the y-axis, x-axis. This is flipping over the y-axis. This one's flipping over this diagonal line. All right, so looking over this is the x-axis. If it ever asks you for the equation of the x-axis, that's y equals 0. This is the y-axis, and the equation of the y-axis is x equals 0. It's kind of opposite what you would think. So this is a horizontal line, this is a vertical line, these are their equations. All right, here you could have cheated and just looked at these, but I'll write it a little bit bigger. The equation of this line is y equals x, and you can see our rule is happening, right? -2, 0 becomes 0, -2. The rule for this line is you just flip the places. Here, this line of reflection is y equals negative x. It's going down from left to right. You can see that we're switching. So like, for instance, if you look at A, negative 6, 3. We changed the signs of both of them. This 3 became negative, and the 6 became positive, and we switched their places. So you can see that we're applying that rule. All right, we should have gone over the rest of the study guide in class, so you should be good to go. You can feel free to email me or text me on Remind with any questions before the test on Thursday. Good luck.